All right, so we have learned about many different quadrilaterals. We've learned about kites, trapezoids, parallelograms, isosceles trapezoids, rhombuses, rectangles, and squares. Now this is the hierarchy of quadrilaterals. All of these are quadrilaterals. Now, a kite and a trapezoid are not necessarily parallelograms. They can be parallelograms, but only if they're special. Remember, a parallelogram is when we have opposite sides parallel. Technically, a trapezoid only has one pair of opposite sides parallel, and a kite doesn't technically have any parallel sides. So these aren't parallelograms. However, there are specific cases in which they can be parallelograms. For example, a kite is also a rhombus, or can be a rhombus, because in a rhombus, all four sides are congruent. And so these two sides are congruent, and these two sides are congruent since all four sides are congruent, which satisfies the definition of a kite because these two sides are congruent and these two sides are congruent. So if a kite is a rhombus, then yes, it's considered a parallelogram. But if a kite is not considered a rhombus, then it is not a parallelogram. So then also a trapezoid. There's a normal trapezoid, and then there's an isosceles trapezoid, in which the legs on your trapezoid are congruent. Now a trapezoid can be a parallelogram if both pairs of opposite sides are parallel, because that would technically satisfy the trapezoid definition. If I have two pairs of opposite sides parallel, then that satisfies the trapezoid definition, which is at least one pair of opposite sides parallel. So going down into here, a parallelogram, there's three different types: rhombus, rectangle, square. So in a rectangle, opposite sides are congruent. If you have an isosceles trapezoid with two pairs of opposite sides parallel, then it is considered a rectangle. A rectangle can, if you have all four sides being congruent, it can be a square. And a rhombus, if you have all four angles being congruent or 90 degrees, that can be a square. A square is always a rectangle. A square is always a rhombus. A rectangle is always an isosceles trapezoid. A rectangle is always a parallelogram. In addition, a square is always a parallelogram, and a square is always an isosceles trapezoid. A rhombus is always a parallelogram, and a rhombus is also always a kite. A parallelogram is always a trapezoid. An isosceles trapezoid is always a trapezoid. A square is technically always an isosceles trapezoid, always a trapezoid, and always a kite. Now how I'm doing this, or how I'm trying to figure this out, is I'm using a set of rules on this hierarchy. If the first category is below the second on the chart, then the answer is always. So we see square is below rectangle. So a square is always a rectangle. The square is also below the kite. So a square is always a kite. Another example, rhombus is below the trapezoid. So technically a rhombus is always a trapezoid. All right. Sometimes, the answer is sometimes, if the first category is above the second category. So going back to my hierarchy, a kite is sometimes a rhombus since it is above the rhombus. A trapezoid is sometimes a rectangle. And then if two categories are not connected, then the answer is never. So looking at the hierarchy, technically, all of these are connected in a way. So there may be instances where we answer never to a statement, and we may get an example of that. But we're going to answer the following questions. The diagonals of a parallelogram are congruent. Now this only happens when we're talking about rectangles and squares. So the answer here would be sometimes. Because a rhombus is a parallelogram, but the diagonals are not necessarily congruent. The diagonals of a rhombus are perpendicular. That is a property of a rhombus. And a rectangle is a square. That is sometimes. Remember, if the category or if the shape lies above the other shape on the hierarchy, then your answer is sometimes. A rectangle is sometimes a square, but sometimes a rectangle is not a square because all four sides don't have to be congruent in order for it to be a rectangle. All right, we're going to draw a picture to represent what's being stated. So for rhombus ABCD, to show that this is a rhombus, I'm going to mark that all four sides are congruent. And whose diagonals meet at E. So let's draw our diagonals in. CE is congruent to DE. Now, this only happens when your rhombus is a square. Because the diagonals don't necessarily are not necessarily congruent on a rhombus. However, if it was a square, the diagonals would be congruent, thus meaning that CE and DE would be congruent here. All right, so now we're going to draw for the next one, rectangle ABCD. We know that a rectangle has all four sides, or all four angles being 90 degrees and opposite sides congruent. And then they want us to draw our diagonals in and have them meet at point E. Okay, so they want to know, is CE congruent to DE? In this situation, it is always. A rectangle has diagonals congruent. And since a rectangle is a parallelogram, the diagonals also bisect each other. So if the diagonals are congruent and they bisect each other, then CE must be congruent to DE. And make sure that you draw your little lines in above that CE and DE. Okay, that's the end of this lesson. We're going to do one more set of proofs in our final lesson.